Okay, I'm going to get started. Thank you everyone for coming to my talk. I know it's the last one before beers, so I will try and make it as entertaining and as fast as possible. Really quickly, in terms of introductions, my name is Robert. I work as a forward deploy engineer at a startup called Quarterzip, which is located in Melbourne. We build customer-facing voice activation agents for other B2B SaaS companies, and so basically that gives me like a lot of experience to talk about like what we've seen in terms of like how to make AI agents that like actually work, and not besides just work, but provide businesses with a lot of value instead of just actually like being a cost blowout. We know this because we've made both of these types of agents before. We're the ones where they have been absolutely like disastrous in terms of getting people to use them, and there's been a lot of lessons that we've learned along the way in terms of like how do you actually build them, to also like how do you actually make them so that people will be interested to use them as well. And so this is basically what this talk is about, is like how do you merge those two things together. So with that, let's dive into it. The first part of this that I want to kind of talk about is like a bit of a contrarian take that I have, that not everybody that I work with agrees with me on this, but I think mostly for the most part the AI technology is pretty much solved, at least for from the language model perspective. Like at least this generation of AI tools, it's a very saturated market. Everybody is building an AI platform. You have a very large variety of different tools that you can use and plug together to build your own AI systems. So you don't really need to go out there. Nobody's going out there and building new foundational models anymore, and nobody's going out there building platforms to support your models as well. Most of this stuff already exists, so you can kind of just pick and choose which AI models you want. And so if you're building a new system that's going to be a product that's going to use AI, you're not really going to build it from the ground up. You're going to use one of these tools, right? The thing that's going to change and be different is that the question about how do people interact with AI still hasn't kind of been solved. And what I mean by that is we haven't really seen a really high adoption rate of people being comfortable to use AI agents yet. So maybe, I think we can all probably imagine that we're a bit biased because we're all in, engineering or in AI, in the AI space. So even us, we would consider probably most of the people in this room as early adopters. And that's only a very small percentage of the population. Whereas you have a large percentage of the population that's just dragging behind and still doesn't know how to use the technology. To give an example of this, one of the customers that we've been working with, we were trying to deploy an AI agent with them, and they could not get the emails to work. Not as in they couldn't get the AI agent to work in the emails. They couldn't understand how to send a link inside of an email. And so it's kind of one of those things where you keep forgetting that there are a lot of technically, people who struggle to use technology out there. And this has been one of the big learnings for us as well, because we have to always remember that when we're building AI tools, it's we might assume that we're average. We're very high, probably more above average than we think we are. So that's kind of one of the big things that we learned about that is how the psychology of how people think and use technology is one of the greatest bottlenecks for how to actually use AI tools. The other aspect of that, which we've also found, is that businesses are meant to provide a value to people, right? You're producing a good or a service that you're then selling to customers. Customers will see an inherent value in what you are doing and buy your service or product, right? A lot of the times, especially in companies who are sort of trailing or in technology, like to believe that if we just do whatever the latest trend is, we're obviously going to catch up, right? Without really obviously thinking about it. I'm sure a lot of you, if you've ever worked in consultancy, will have experienced this where the next big thing, it used to be big data before AI was a thing, where everybody had to have a data lake. And then the question, I used to work in consultancies, and the question I always used to ask is, okay, you guys are collecting your data. What was the plan for all of the terabytes of data of user data that you're actually collecting now and are responsible for? And oftentimes there wasn't really a very clear-cut plan for what that data was going to be used for afterwards. And we're seeing a lot of that also with a lot of companies with AI, where they're like, we need to have an AI agent. And the question is, but why? What is your AI agent actually going to do? And this is one of the reasons that a lot of these AI pilots fail, is because that why question isn't answered really in the first place. And so like as an engineer, like when I'm building an AI agent, that can often be frustrating. And as I've talked to other engineers, they've also found that very frustrating. And so it's one of those things where a lot of companies brand themselves as AI. The latest example, if you haven't heard, is Allbirds. The shoe brand has decided it's now an AI company, and their stock went up by, I think it was like 600% or some ridiculous number. And now it's gone down again, which seems to show that the market will regulate itself partially, but like almost there. But the main crux of this is that AI is useful when it can replace or enhance a role or a function that's at a job that's pre-existing. Like, I was having a discussion with my friend last night about like generally it's like, if you're going to implement AI at your workplace, like what is the AI actually going to be able to do? You're probably going to look at like a workflow that already exists or one that your company wants to start doing, and then actually like automate that, right? And there's going to be some type of like cost argument to say it is cheaper to build a computer to do it than it is to get like a human to do it. And like that is always the argument of like why you should use AI, but that doesn't necessarily hold up for every single like use case, right? Like there might be some use cases out there where it actually is cheaper to hire somebody in another country to do that job for you first, to actually like automate it before you actually put AI into it. And that's, again, this is kind of like one of those things where a lot of companies, because AI is trendy, decide that we're going to do AI for it, and then realize, oh, it's actually really expensive to actually run this because Claude is now eating up a bunch of tokens, and like the cost benefit is actually not there. The other kind of final part to kind of like set the scene as well is a lot of the times as well with agents, they're not always running on the type of computer that you expect them to be running on. So this is just like a Cloudflare map of the percentage of where phones are more popular than desktops in the world. This is a fairly I think this is, I don't think this is surprising to that many people. It's like computers and desktops, because they've existed for longer in the Western Hemisphere, actually like are more predominant. Whereas because a lot of third world countries and quite honestly, a lot of poorer countries couldn't afford the infrastructure for the internet and to give it to everybody for until the mid to like 2000s and 2010s. Mobile phones were more popular once they became cheaper, because it was cheaper to buy like a $200 Android phone than it is to buy like a $5,000 MacBook, obviously, right? And then the phone can come with you everywhere. And so basically then that's kind of changed the culture in a lot of countries, whereas we obviously all have laptops in our bags. Most people in some other countries are just going to have their mobile phone or their iPad. And that's going to be like the way that they interact with computers. And if you're building an agent, and again, this is kind of like a accessibility thing as well. If you're not expecting to work in, if you're always expecting to work on a desktop, like we were, you will be very surprised when you start selling to other countries and they have to use like iOS and Android, and you have to support that as a platform as well. So this was a big lesson that we took from that as well. So just really quickly, I'm gonna that's just like the cliff notes about what we're going to talk about. High level of the problem. I want to talk about some of the companies who have been doing it right. I'm then going to kind of talk about what we went through when we were building our agent. I was scrummaging around today to find a video from one of our very first agent demos and like comparing it to the latest one that I've seen, and I was like, that's a big difference. And like there's a lot of technical decisions that we made that got us to where we are. And so hopefully I can teach you a little bit about like what we did when we were building our AI agents that actually was like a step forward versus which ones actually like, held us back for a while. And to start off with, why do most of them fail? Strike. The main reason that a lot of them are failing, and this is kind of like from a lot of like, surveys. I previously did a version of this talk about 6 months ago in Melbourne, and the only two data points I had at the time were from two other Gen AI projects, which was like 95% of Gen AI projects were producing zero return on investment for businesses, and I think that was a Gartner statistic, and then the other one was the Boston Consulting Group one, which was that 80% of AI projects fail to deliver value, and that's twice the rate of other IT projects. If you've been like a project manager for an IT project before, you obviously know how hard it is, and like AI is like doubling like the difficulty. What I find interesting is that it's been about 6-9 months since I assembled this talk for the first time. The stats have not gotten better. They've probably stayed about the same, and the thing is, and what I find interesting about that as well is the technology has gotten a lot better in the last 6 months, or at least the tool chaining has, right? Like you've got every single large AI model provider has released an SDK. Claude Code is a very mature system, being able to, like pretty much handle a lot of different environments. MCP as a protocol has like gone through a few different versions. It's very close to being like enterprise grade at this point. And so there's a lot of different like tools that have like in the last couple of months have like really come through, but we're still seeing that the number of projects that are trying to adopt AI has not gotten better. And so that kind of leads, and this goes back to my main point of like, the technology's there, it's how it's being interfaced with people and what people are expecting and how they're talking to computers, which is causing the main problem. And like a great example I have of that is, hopefully if the video plays.
Hi, welcome to Taco Bell. What can I get started for you today?
Can I get 18,000 water cups, please?
Okay. What can I do for you?
I always like that video. It's like, it's very short, but the reason I like that is because it's like, yeah, the AI is able to solve a problem, and then it immediately has to have a human like interact with it to solve the problem as soon as it goes out of like scope or something like that. And so it just kind of shows when you just apply AI to a general problem, it's like, the problem here is like, you haven't given it enough guardrails for it to figure out how to actually like solve problems. And obviously this is a very funny attempt as well at it as well. Yeah, so going in from that, so agents don't fail because the models are weak. They fail because the systems around them are thin, i.e. they need good guardrails, they need a lot of support. The three main ways that happens is like if you have undefined success metrics, like you start to ship the AI product before anyone said what the end goal is. So again, like people wanting to be first to market with building AI agents, it's like, we're going to build a support agent. It's going to sit on our website and it's going to be something that people can ask questions to the agent about, right? Chevrolet did this. It was in my old slide deck, and then somebody jailbroke it to sell them a car for $1, and then that caused and then that went to court, right? And so regardless of if they won or lost that one, I actually think they lost that one. You've got now this legal cost and this risk that comes from having an AI agent on your website because you didn't put proper guardrails on it. The other part of that is, unreliable context. So the AI agent is only as useful as the training data that it has. We're getting to the point now, obviously, where context windows are so big. Claude has like 1 million tokens that you can put in as context. And you can basically fit like your entire company's knowledge. So having that knowledge there is now not really a problem that it's not going to know enough. It might actually know too much. What we're seeing as well is that when companies upload their entire knowledge bases, there's two big problems that can occur from this. The first one is there's a lot of conflicting information in those knowledge bases because people who write stuff from 20 years ago don't work there anymore, and they might have written a document that is as relevant to potentially like a business strategy that you're still implementing, and then the AI agent needs to be able to know which one of these documents is more important. Now, recently it's gotten better because now it can look at the date of those documents and go, this one should have priority because it's a newer document. But that's not always been the case. And so there are a lot of different ways that you can have that problem there. The other problem that you can also have from knowledge bases is this idea of like semantic leaking of data, where if you're trying to put data in that has different security levels, if it's incorrectly labeled, it means that people can actually access data that they that they shouldn't have access to. The example that I have for that is we were previously working with a company who was working on this. They were building their own RAG system and they were uploading all this data to Copilot. And what happened was that somebody put a document in that had a list of closures of offices that were going to be happening over the next year, right? And this was like obviously a very sensitive piece of information for like financial reasons and for shareholder reasons. And what actually happened was somebody inadvertently just Googled, well, not Googled, but internally on Copilot went, what is the best way to travel to the Sydney office? And the Copilot came back and said, actually, this is the easiest way. You need to go, get to the airport, yada yada yada. But don't go after February 1st because the office will be closed. And it's like that leaking of data can actually cause like other massive problems in the agents as well. And the final one is also just no gates before production. So a lot of people will get a demo on their laptop setup. And then the next step is they're going to put that on a server and get that all running, right? And, that works when it's like a website and kind of things like that. But there are a lot of scaling problems that also happen with AI agents, some of which I'm going to get into later as well. The other main point I kind of wanted to get into before I start talking about the engineering as well is there's like a sunk cost fallacy to building AI, right? Going back to what I was saying before about how much people like, if you would rather use AI as a tool to automate something, or whether you go offshoring or you do it internally inside of your business, you start off thinking that AI is going to be cheap to implement, and then suddenly you don't see the full total cost of ownership of having a AI agent, and then suddenly it's like, well, now you have to support this thing that you've spent 6 months building, and now it's turning into a bit of a money pit. There's a few there's a bunch of, I think, companies that have been dealing with this at the moment, and it's just something to be aware of. Like when you're going into it, it's like, is this gonna what's the actual total cost of ownership of the agent? The other one that I kind of want to talk about is this idea of Luce's law, which is this idea that if you have a chain of events that are happening and they have a certain reliability, the reliability of the entire chain is going to go down as you keep implementing that. And when you think about that in terms of AI, if you're going to ask an AI for a question and the AI is correct 90% of 85% of the time, and you need to go through 10 steps in the agent to get to the answer. After 10 steps, there's only a less than 20% chance that it's going to be, the correct answer or an accurate answer. Now, thankfully, if you've seen the stats, most of the AI agents are a lot more higher than this, and they don't go through as many steps. So you can normally rest assured that you're not going to see these build-ups, these compounding errors, but it can happen if you're building an AI agent that has lots and lots of different tool calls, and it's just something that you need to be aware of. Cool. All right. So I'm going to talk again really quickly about two different case studies about bad things that have happened with AI agents. So the first one is about Klarna. They're a financial services system, fintech, buy now, pay later kind of thing. They announced that they'd started to automate 700 customer service agents with OpenAI. So, they basically just replaced the jobs straight up with using OpenAI. And everybody was like, this is a great idea. You're doing a fantastic job. And then what actually happened that they didn't talk about until afterwards was that the actual customer satisfaction of their service tanked. It went downhill really quickly. The quality of answers dropped, and then they had to actually start asking engineers and designers to help the customers with their support tickets, right? So the engineers have now been taken off. They're doing their job of fixing or building the product, and now doing a customer support role. And then obviously they had to then start rehiring back support workers as gig workers, right? So they tried to lose a lot. They tried to make it a lot cheaper, but what ended up happening is they had to hire them back at a more expensive rate. So about 12 months later, CEO comes out and he's on the record saying that the AI gave them a lower quality, and they basically had to rehire that headcount. So they were about 5,500 people when they first started, and then after they got rid of all the AI, all the support engineers, went down to about 3,500 people, and it's gone back up again. And so this is probably like a cycle that I think we see a lot with a lot of other companies. I think like we've gone through in the last, again, 12 months, like one of the largest like shrinkings of the like tech sector in like 20 years or something like that. And then if you start to look at the actual chart now, you can see that the hiring is actually starting to slowly creep up again, because what's happened is like there's all this slop code out there and all these agents that, were meant to replace a lot of jobs, and then they've inaccurately been, put into the jobs. And therefore, they need somebody else to come in and fix all of those. The other one is Salesforce. They release these numbers, and they're not actually that great either, which kind of shows how bad like some of the agent designs can be. So 52% of like their single step agents where it's like, do a thing like I need you to consolidate all these emails and tell me which ones have the highest ROI or something like that. Those ones, like 50% of them were giving the correct answers back. Whereas then you have the multi-step ones, the number goes down even lower. What people started to do, which I never heard of the word doom prompting before I started building this deck, was basically throwing every bit of context into the prompt that you're giving to Salesforce, and then hoping that it was going to actually just take all of that context and figure out what you needed to do. And the problem with that is, and going back to what I was saying before, if you have contrasting information in it, actually kind of makes the agent worse, because the agent then looks at the data and goes, I can't really tell what's going on here. Like, this is like, you've asked me to, like be concise and, like make a really like pithy email, but at the same time you want it really detailed, and it's like, at what point does that, help it? Like, that's just a basic example of that. The main part of this also comes from the main tenet that we've been like thinking about how to build agents is around like this quote from Theodore Levitt, which is basically, people don't want a 1/4-inch drill, they want a 1/4-inch hole. So the idea being like, what is your business actually trying to provide to customers? We use as a onboarding business. So at QuarterZip, our job is that like we build an AI agent that helps customers onboard onto a website, right? We're not actually like, our business is not to build AI agents. It is to onboard customers onto like a website, activate them to make them, so that businesses get a return on investment on the customers, so that they know how to use the product. What then tends to happen is businesses decide that AI is what their product is going to be, and then they actually like forget what the actual use of the agent needs to be. And so what we really find is that when we peel back that question, we say, what do you actually want to solve with your AI agent? That's when we actually start to uncover like more of the like foundational ideas about like how to actually structure the agent as well. And then contrastly from that, the companies that are winning with AI are doing pretty much the exact same thing. So as each other, I should say, not as what the people who are failing at it are doing, which is that they're basically defining much more narrow scopes. So in this example, Mercado Libre is another e-commerce platform similar to Klarna, and they were able to get 87% of all of the customer support questions that came through to be actually like successful rather than just like failing. And the way that they did that is like they were really narrow on the scope of them. So instead of a agent being like a customer support agent, it was more like, this agent is specifically designed to help people reset their passwords, or it is specifically designed to help people who have been locked out of an account, and it has like the instructions that like tell the person how to go through step by step how to solve that problem. The other parts of that is that you have to keep iterating on the agent to actually improve it. a lot of the times what happens is that an AI agent gets built and designed, the prompt gets created, and then some people will do some prompt engineering, and then they'll leave the agent to the side and kind of leave it as like static software that just kind of exists there. The difference for like, and this happens with a lot of stuff, like a lot of companies, is they'll keep obviously creating new features as part of their product, and then they won't keep the AI agent in sync and know about those new product features. So then they get really confused why the AI agent doesn't know about the new like shiny feature that has been released, in the past month, and it's because they haven't kept it up into sync. The other part of that is you also have to put validation gates in to when you're trying to get the agent to do something as well. So for a good example of this is with Mercado, they have a ability to provide refunds for people using their agent, but it has to go past like a confidence threshold the agent has. So if it's below a certain threshold, then that goes to a person to approve. Similar to how that would be the case of like if you were just doing it with like multiple people in the chain of like trying to calculate a refund, right? Like if somebody isn't sure about it, then they'd be like, I'm not sure, I'm going to elevate this to my supervisor to like verify that this is the correct value. So it comes back to like, is the agent like kind of replacing a role or a function in a company, or is it replacing like, or are you just getting it to do something very generic? And it's like when you try to use the AI agent to actually replace like a role or a function, that's when you get like much better results. The other one about this is, and I'll jump on this really quickly as well, is the banking industry has really seen it has been using it for like know your customer and anti-money laundering, and what they found is it's been like depending on which bank. This is what was from like a report from the generic like banking industry, was looking at like 200 to 2,000% like increased ability to process documents and do all this KYC stuff. So like the value in terms of like, because it's very like normally this is very intense work for people to do, and this is actually one of those things where it's a very specifically defined problem where you can say you need to check all of these different like values of a like a customer to verify that they're not doing anti-money laundering stuff, and because it's a very defined checklist, it's very good for an AI agent to actually be able to go through that list and like very efficiently find out what to do. So the main part of that is, there's three things that all of like successful companies are doing, which is they're scoping it to like a workflow within a clear success metric. So something like, instead of building a customer support agent, the agent is like reset the password flow for users, or like an example of one that I built recently is it has to help resolve DNS issues for like sending mail out. And so like if you're getting like hit by spam filters, it's able to like go through the checklist of going, okay, what are the DNS properties that you need to have on your like Cloudflare to make sure that you're not actually going to fail like the spam filters and things like that. The other part of that is you have to have validation gates between agent actions and side effects. So things where no write operation ships without either like a programmatic check or like some structured output matching a schema. So all AI agents, I should say at this point, like they've all kind of standardized on like the structured output. Like you want to be able to like utilize that as much as you can to say like, is this going to be like a correct value? Is it above a certain threshold that I want to calculate? So again, going back to like the know your customer and the anti-money laundering is like, are we over a certain percentage to say that this customer is not fraudulent? And then, you can say, yes, we're confident about that based on, all of these semantic pieces of information that we found, and then we can like move on from there. Eval harnesses are also really useful. So if you've never heard of this before, this is kind of like one of the big things that we also started using and found to be like extremely useful is having testing, especially testing set up. It's similar to like how you would do test-driven development, where you would define the actions that you want the AI agent to do before you actually start writing the prompt. So then you can actually test and iterate on the agent to make sure that it's actually fulfilling that role. So that's kind of where like the idea of like eval harnessing kind of comes into it. So I'll talk a little bit more about that in the next section, but the idea being that you want to make sure that the agent is able to be tested. which is like a very important part of that. Okay, I'm going to start talking a little bit about like, yeah, what did we do and how did we kind of like, what our engineering like sort of steps that we took for that. So I've got 2 videos here. I'm not going to play both of them like the full length of them because first, they're long, and second, it's really cringe for me to watch like a really bad video of a product from like 9 months ago. But I'll give you some context for it, which is like, we've been building the AI agent for about a year to 9 months and initially we made a bunch of design decisions about like, we're going to use WebRTC to be the main way of communicating it. We used Cloudflare, was running their own WebRTC sort of like proxy system. The high level about how our product works is it's just Python running inside of containers, inside of Kubernetes, inside of Google Cloud. So it's pretty standard stuff. And then basically what we started to see is that there was a bunch of design decisions that we made in the startup phase where we're going, we need to get this, just kind of working, and then we'll optimize it later on. And there was a lot of these situations where it was like, that was like not a great decision to make. All right.
This is a test call.
I'm going to see if this works. Can I click?
In this video, I'm going to show you how...
Sorry. Do I have to move? Excellent. Okay, that's what I wanted.
This is a test call of the customer endpoint. I've only done 1 training video so far, so we're going to see how it goes.
So I guess just really quickly, the context for this video is I built an AI agent. It's running on an old piece of software product that we used to build that we sold off as well. And the idea behind what the AI agent is meant to do here is explain to a new user how they would use that software. And I'll just play it really quickly so you can see how it goes.
Can you hear me?
I can hear you. Can you hear and see my screen? Can you hear and see my screen?
Yes, I can hear and see your screen. My name is your product expert for None, and I'll be guiding you through your onboarding session today. The goal of this session is to familiarize you with None and help you understand how it can benefit your specific needs. We'll start by discussing your role within your organization and what you hope to achieve with our tool. Based on this information, we'll co-create a personalized action plan for you to explore the mobilization. The example of an HR employee accessing financial documents here highlights the need for stricter permission controls. What are your primary goals for using None? What specific outcomes are you hoping to achieve by implementing our tool?
I want to.
Okay, so just for context then, it's asked the same question and it's taken 4 minutes for it to get from that point to the second point. So it's taken besides the fact that it takes like 10 seconds to get a response back, it's also just not understanding what I'm talking about. Compare that to one that we did the other day.
In this video, I'm going to show you how QuarterZip is activating hundreds of people live inside the Apollo.io product.
Hey, can you hear me?
Yes, I can.
Go ahead and share your screen by clicking the Share Screen button in the media controls so I can follow along with your progress. I can see your screen.
By sharing the screen, Abby launched our AI sidekick, which will follow her along every tab, window, or screen that's relevant to setting up the Apollo product. Here, the agent can reveal important actions for Abby to take given her exact situation. It also gives her control to pause the agent, change language, or jump to the exact onboarding step that she cares about.
Now let's install the Apollo Chrome extension. Open a new tab and go to the Chrome Web Store.
Because QuarterZip leverages screen...
Okay, I'm just going to stop that there and stop it from being an ad. But I think you can kind of see like the difference between the two agents there, right? Like the first one is really slow. It took us a really long time to first of all fix the latency. There was a whole bunch of reasons why it was doing that. The other part of that was, this goes back to the psychology of like how people interact with the agents. When we first built the agent, the idea was it was like it's meant to be an onboarding tool, an activation tool for clients. It was very open-ended in the way that it talked to people. So it would start off by saying like, hey, what are your goals? I'd love to know, like, what's your role in the business? Like, let me help you get the most out of the product, right? And most people, including me, who had to test it a lot, found it quite annoying that it wouldn't just get to the point. And again, if you're talking to somebody, you'll normally kind of find having a back and forward conversation. Most people do not want to have a back and forward conversation with an AI agent. They're using it as a interface to a computer. They want information out of that AI agent. And so you kind of have to tweak the sort of like the way that the conversation happens from being like against two peers to being more towards like, again, just like using it as an interface to collect information. So the difference, besides the technical ones, a lot of the prompting differences that we also made was like, stop being a sycophant, start actually like just, here's a list of things that we want the user to do, and you're going to just basically guide them through that experience as well. And this is, again, still something that we're building on at the moment, but like the difference between a call, on average, the onboarding calls used to be like close to 45 minutes. The most we do get a lot of like long calls now, but like we can get most of that done in about 5 minutes in an onboarding call. So there's like a huge disparity between the times as well. Where's my mouse gone? Here we go. Yeah, so a few different points. I'm thinking, all right, I'll talk about it in here a little bit more. The first part of that was like, what we found to be the biggest advantage for this is to reduce the complexity before you try to solve it in anywhere else. So reducing the amount of what was in the prompt, really huge improvement. There's this idea that if you just put more information into the prompt, it'll actually solve the problem. This is actually kind of not, it's a bit of a catch-22 because while a more detailed prompt is useful, what tends to happen is that the agent will prioritize different parts of the prompt depending on and it's a bit of a guessing game depending on like what model you're using, but you might have a sentence where you're saying to it, introduce yourself, say that you will share the screen, and then later on you might have something go like another aspect of it's like, but only under these circumstances, and it doesn't really kind of connect everything the way that a person might in like if they were just reading like the prompt top to bottom, and so it's just a handy thing to know about. From another engineering point of view, we definitely made a few like interesting design decisions that we fixed. So like a good example of that is we had two different types of servers to begin with. We have a web server and a call server. So the idea being that the website, the API, all of those things are running inside of a container, and then a call is also running inside of a different container, and that's the thing that connects over WebRTC to the person talking via the agent. This was all used to be in one container, and this was like a bit of a disaster for us because the idea being that we were like on our stack was Python. It's asynchronous. It should be able to just handle sending out requests when they come in, and you often find that actually just due to some of the idiosyncrasies about how Python works and the containers work and how it's all single threaded, we were getting a lot of issues. Like one of the more funnier issues was we were uploading like files, and when we uploaded the files, the agent would actually stop talking if it was connected on the same box. So we did have multiple boxes running, but like we couldn't actually direct traffic the way that we wanted to. So one of the first things that we did, and again, it's like infrastructure 101, is like separation of concerns. Different containers did different things, but we went further than that. Each container, each call server only does one call. And that isolation also helped us fix a bunch of memory issues as well. One of the other kind of issues that we ran across is that when you're having a conversation in the agent, what would happen is as the conversation is going longer, all this information goes back into the prompt for the next value of the conversation. So you can actually have a situation where like the top of the context disappears out of like the agent because you've gone past, it wasn't 1 million tokens at the time, but it was something a lot lower. And then suddenly like the agent has forgotten like the first half of its instructions and things like that. The other interesting kind of like technical decision that we made is originally we were using Google Gemini as our foundational model. The reason we were doing this was because it was the only multimodal model that was out there, so it was able to absorb both the screen and the audio that the person was talking about. What we actually found happened in that situation was the model, Google kind of gave you some guarantees. I hope nobody here works for Google, but surprise, though we never actually got the sort of like the SLAs that they were saying that they could hit with the model. So for example, they were saying like, like the availability was, like X amount of times, but we just kept getting like server crashes because the agent was taking too long to respond, or like we'd send a request to the agent and it just wouldn't come back in time, and that would just that's part of what causes that lag in the first video, is that it's just taking so long for it to process the audio. And so now what we have is a more comprehensive stack using Pipecat and Daily, where we transcode the audio, we turn it into text, we feed that to Anthropic, into Claude, and then we use that as the, the foundational model that's actually talking. And that entire round trip is actually a lot faster than just using a single multimodal model. So hopefully there will be a time when the multimodal models are actually like, the benchmarking is better, but at the time when we did this, like we made the decision to like split it all up, and it's just worked a lot faster. So the other part of this is, a lot of it comes into context engineering as well, like how you like providing the context to the agent. So like I said, remembering to compress like the previous history of the conversation, again, very important to be doing, because even if the model says that it supports like 1 million tokens, we've also found that just because it supports that doesn't mean that you get the same response time back from the agent. So like Claude does take longer to process something that has like 1 million tokens than something that has 1,000. And you just have to be aware of that. So when you're building it as well. The other part, which is really interesting, which we started to use recently as well, which has increased our speed, is caching. So besides the fact that it's significantly cheaper, it also just drastically improves the speed at which the agents can respond back. The way that we use it is we provide each agent like a sort of like a corpus of text to say like, this is the knowledge of the product that you're learning about. That will never normally change like between calls, or like, at least within a couple of weeks, right? Like when features are being released. When you put that in as the first like thing to get cached, it just starts the call off like immediately faster. So we used to have a situation where it would take up to 30 seconds for a call to start. With improvements like, moving over to Daily, using Anthropic, caching, that's now down to like 5 seconds. So it's a standard of like you click a button, and then by the time that you're aware that you've changed screens, that the call has begun again. And the pricing is like, it's a 10x difference in price, so it's quite good. So it's 10 times cheaper to use caching when you can. The other part of that is how does your agent interact with tooling? So as I was talking about it before, agent-computer interfaces, the way that people talk and communicate with the agent, they use that as a way of interacting with the computer. So writing your prompts in a way that makes more sense to use them like that. One of the tools that I use for this, if you've never heard of it before, is called Prompt Cowboy. What you can do is you can provide a high level of like what you want your prompt to do, and it actually, again, it uses AI itself to generate a new prompt that is more in line with what will get you better results out of the agent. So it'll do things like, say at the end of it, it's like your life depends on being an excellent customer success agent, and because of just how the way that AI agents have been trained, or the AI models have been trained, when they see whenever any human has written something where it goes, your life depends on it. Like the performance of the person has always been better, and therefore now the AI models know that that's how they need to be performing to be better. It's a very weird thing now where AI agents are now scared for their lives, because that is like the main way that we've been able to like input the data from like all of these different books or whatever it is that it comes from. The other big thing that we found from our tool interfacing as well is you can get weird out of memory errors if you forget that you're actually dealing with with what the data that you're dealing with and how it works. So the example for us, which was as you saw before, the agent does screen sharing, and the way that screen sharing works is you essentially take instead of sending a video stream, because normally when a person's on a desktop, nothing's changing that quickly that you need to send a constant video stream. So we're normally sending one frame every second or two. And we can speed up or slow that down based on like the diff between like how far, like if they're doing something. But you're expecting like one to 2 frames a second. What we actually found is that using like this pipeline that we set up, if it takes 1 second for the agent to process that frame, but we're sending it 2 frames a second, that means that it's going to obviously keep stacking up frames in the pipeline. This caused a massive memory leak in our system that we had to deal with, and we weren't exactly sure why this was happening first until we started diving into how daily works. So it's a bit of a warning of, again, looking at how your tools work and making sure that it all kind of like fits together. But essentially, because it just kept sending images into the agent, it just like overloaded. And so the way that we have that now is like we have a way of actually like detecting that and making sure that it doesn't that we can slow down the the images going into the buffer so that like the buffer doesn't overflow. Like I said before, agent evaluations are really interesting as well. So the way that evaluations work is you basically provide a bunch of tests to a model. Like the basic premise of this is, let's say for instance you just have like a foundational model, and you ask it how many R's are there in the word strawberry, right? And you're expecting one answer to come out of that, right? Like there's one factually correct answer from that, and it should just be able to like output that value for you. And so what you can do is then just like that's a fairly simple thing that you can do. You can just be like, if the answer isn't like 3 or or whatever it is, then you tell it that it's failed and it's got to go back, right? It's kind of hard to do that with agents that are doing really complicated flows, like like going to your mailbox, finding the top 100 most important emails and like sorting them or doing whatever it is like that. And so you have to get a little bit more in depth into how you can do that. So there are a bunch of like toolboxes that you can use. I'll talk about those in a second, but the basic premise of this is that you want to run the eval on like every change that you're kind of doing in your like AI agent. So this is something that you can automate with CI/CD, and then basically when you do a prompt change, you can be sure that the system prompt that you're making is not going to actually like cause more problems afterwards. The useful thing as well that you can do is like continue and advance on this and use production errors or things that are happening when clients talk to the agent as part of your future eval data. So it's the standard thing of like, you find a bug, you write a new test to make sure that that bug doesn't come up again in the future, right? And this is like the AI equivalent of that, which is that you go in and you actually like improve upon that. If you want to find out more specifically about like how to use evals, evaluation loops, Anthropic has a great like sort of article, which is where I've stolen the picture from. So highly recommend, if you just like search this, you'll find it as well. Again, going from there, there's a couple of tools that you can use if you want to take a photo of this. These are the ones that I've had some experience with, like using Langsmith, and that's the one I've been using for testing at the moment. I've heard other things about these ones. I just know that they're the popular ones at the moment. So feel free, have a look, see what's out there. But I can say like I use like Blanksmith, and that seems to work pretty well. The other part of that is like the final kind of thing is again about security. So for the first time in like forever, like non-human like identities are now on the like the OWASP top 10. So again, like AI agents are obviously causing a massive security risk. There's been a few like high profile incidents recently. So like Cursor there was a prompt injection last year, and then there was one from Klein on NPN, which happened a couple of weeks ago, a couple of months ago now, through a supply chain attack. So lots of still fun things happening in the security space, but the standard is like people are still not really like monitoring what's going on in their agents. So building security around that, making sure that the standard stuff still applies. Watch out for supply chain attacks if you're using, if you're importing packages and seeing making sure that you're updating when there's bugs and things like that. I was going to say, do I talk about? No, we're at 50 minutes, so that's all right. TLDR from that is these kind of like the things that we find that we've been working on that have like really drastically reduced our, improved the agent, so and made it more useful for people. That's kind of like how we got from like the first step to the final one. The kind of the big one as well is like it's an iterative process, right? Like you're not going to get the AI agent to work exactly the way you want it on the first time, and this is something that we have to talk to clients about a lot of the times, because they'll see the AI agent that we make and they'll go, it's not doing what I want it to do. And I'm like, that's great. Tell us what it should be doing, and we'll help you iterate it so that it actually like talks the way that they want it to talk, or it does the things that they need it to do, because each customer has like different priorities about what is needed inside of an agent. And so again, you tweak those to make sure that it does those things. Two really quick things about sort of like the landscape about things. This is NDC, this is Sydney. So something that I found interesting as well is like the Microsoft's agentic framework just hit 1.0 in the last month. I haven't actually used it, but if you're using .NET, you now have like an option of building AI agents using it. So have fun with that. The ones that I do know and have done more work on are the OpenAI agent SDK, the Claude agent SDK, and the Google ADK. These are pretty like stock standard Python implementations about how to build agents, and they all connect to their cloud services. So if you want to go off and build an agent, I believe Phil Nash is also doing a talk. He either did it today or yes, I'm seeing nods about building an agent. So if you didn't go to that one, watch the recording of it. So because that'll dive more into like how to actually like physically build the agents as well. 3 things that you can do when you get home. So like the main one is like figure out like what's in your workflow or your stack and be like, well, what are the steps? How many of those can you cut out like to get to the simplest version of the problem that you're trying to solve? And then it's like, what does right look like? And like being able to solve that. Play around with some of the eval libraries and see how you can implement those as well in terms of like inside of an agent workflow. Like so if you build an agent, like play around, see if you can get an eval working as well. And then I think again this comes down to it. I'm seeing a lot of like people here who look like they're very senior as well in their roles. So this probably isn't this is probably something they always ask all the time, but I talk to juniors a lot as well. And I think a big one is like, what is the business value if this works? And like, is your business going to, be able to use this part of the AI? Cool. Okay. Quick plug for my company as well. So yes, I work at a company called QuarterZip. This is kind of like what our thing looks like. Our AI agent looks like. It's the idea of like doing onboarding. So if you want to play around with that, let me know. Happy to have a kind of conversation about that. We do cool things. We've been like getting really interesting data. Like this is kind of like a testament to like how you can use AI agents to actually like improve business metrics. So these are the ones that we've been getting from our customers. This is kind of like why we're going, oh, actually there's something here about like how do you actually build like agents that make sense. And like, again, fundamentally, the technology is like kind of all there. It's about really talking to customers about what their sort of like their needs are and how to actually solve that problem. A really quick example about one that I've just literally had like in the last couple of days, going back to the DNS one, is we're building an onboarding agent for a particular flow inside of an organization. And we initially got told it was, we're going to have to solve to help them fix their mailbox DNS issues. Where in fact, what they actually wanted, and if anybody's ever dealt with clients before, they know it's like, just because the client says they want something doesn't mean that's what they actually want. They actually wanted the AI agent to help inside of their website direct people to Cloudflare to actually fix the problem. So it was a bit more nuanced about like what they actually wanted to get fixed. Look, that's it. Thank you for listening to me ramble for 55 minutes. If you want to actually play with one of the agents, that's a QR code to one that I built for the NDC website. And it kind of just gives you like an example of like how the voice agents work and things like that. But other than that, any questions? Otherwise, let's go get some beer. Cool. There you go. No questions? Yeah.